Ever look up at the night sky and think about how it all started?
It's amazing, right?
Yeah, it really is. I mean, all those stars and galaxies, it's mind-blowing. And today, we're doing a deep dive into one of the most important parts of how the universe began.
It's called reionization.
Reionization.
Yeah, it's basically like a cosmic makeover.
A cosmic makeover, huh? So like a glow-up for the universe?
Exactly. Like the universe was kind of going through a dark phase, you know?
Not a teenage phase?
Kinda, and then bam, reionization hit, and it became the radiant spectacle we see today.
So how did this all start? I mean, where do we even begin with something like this?
Well, we got to rewind all the way back to the Big Bang.
The Big Bang, okay.
So right after the Big Bang, the universe was super hot.
Yeah, I imagine.
Like crazy dense, just the soup of particles.
Okay.
But as it expanded, it started to cool down, and that's when we get to the Dark Ages.
The Dark Ages, so is this like when the lights went out in the universe?
Not exactly. It's more like, imagine trying to see through a really thick fog. Yeah, the universe was filled with this neutral hydrogen gas.
Oh, okay.
And it was so dense that it basically blocked all the light.
So no stars, no galaxies, just darkness.
Pretty much. But that's where things start to get interesting, because within this dense fog, the first stars and galaxies began to form.
So like little beacons of light in the darkness.
Exactly. They were the pioneers of the universe, and they were unlike any stars we see today.
How so?
Well, for one, they were massive, like hundreds of times bigger than our sun.
Wow.
They burned really hot and bright, but they didn't last very long.
Okay, so we've got these giant stars blazing away in the fog. But how did that actually clear the fog? I mean, we're talking about clearing out a whole universe.
Right, so these stars, they weren't just shining, they were emitting intense ultraviolet radiation.
UV rays.
Yep, and that radiation had enough energy to ionize the neutral hydrogen.
Ionize. So what does that mean?
Basically, it strips away the electrons from the hydrogen atoms,
Okay.
and that transforms the gas from opaque to transparent.
Oh, I see. So these stars were literally changing the structure of the universe.
Exactly, they were making it possible for light to travel freely.
That's pretty incredible.
Right.
And how long did this process, this reionization take?
Well, it wasn't a quick process. We're talking hundreds of millions, even up to 1 billion years.
It's 1 billion years. Wow, it's like waiting for a website to load on dial-up.
Haha, yeah, something like that. But it's important to remember that this didn't happen all at once.
So it wasn't just like flicking a switch.
Oh, it was more like a gradual, patchy process.
Patchy.
Yeah, imagine like a cosmic patchwork quilt where some parts of the universe had cleared up while others were still shrouded in fog.
A cosmic battle between light and dark.
Exactly. And that's what makes studying this era so challenging, but also so fascinating.
I can imagine, and our sources mentioned the James Webb Space Telescope as playing a big role in this cosmic detective work.
Oh, absolutely. The James Webb is a game changer. It can observe infrared light, which means it can see through those remaining patches of fog.
So it's like having a time machine.
Kind of. It's allowing us to see the very first stars and galaxies.
So from a murky universe to a transparent one, all thanks to these massive stars. It's amazing how much impact they had.
It is. And it really highlights how important reionization was. It was a turning point for the universe.
Without it, we wouldn't have the galaxies and stars we see today.
You wouldn't even be here.
That's a pretty big deal.
Yeah.
So this glow up, this reionization, it wasn't just temporary, right? The universe didn't go back to being murky.
No, once the hydrogen was ionized, it stayed that way. The light stayed on, so to speak.
That's good to know. But it makes me wonder, what were these early stars made of? I mean, they formed in a very different universe than we have today.
That's a great question, and the answer is pretty fascinating. These stars were almost entirely hydrogen and helium.
So no carbon, no oxygen, just the most basic building blocks.
Exactly. They were formed from the stuff that was created right after the Big Bang.
So they were like the first generation of stars.
Precisely.
Wow. And that's where we'll pick things up in part 2 of this deep dive into reionization.
Yeah, the first generation, and they played a crucial role in creating the elements we see today.
So how did they do that?
Through nuclear fusion.
Nuclear fusion.
Yeah, it's how stars create energy.
Right.
And in the process, they fuse lighter elements into heavier ones.
So these early stars, they created the first heavy elements.
Exactly. Like carbon, oxygen, all the stuff that's essential for life.
Wow. So the carbon in our bodies, the oxygen we breathe, it all came from those early stars.
It's pretty amazing, right?
Yeah.
They're literally made of stardust.
Stardust. I love that. So these stars, they created the heavy elements, and then what happened?
Well, eventually they died.
Died. How?
They exploded as supernovae.
Supernovae.
Yeah, these massive explosions that scatter all those newly created elements out into the universe.
So they basically seeded the universe with the ingredients for planets and life.
Exactly. And that's why reionization was so important. It's not just about the universe becoming transparent. It's about creating the building blocks for everything that came after.
It's like setting the stage for the universe we know and love.
Precisely. And it's mind-blowing to think that these events that happened billions of years ago still have such a profound impact on us today.
It really makes you feel connected to the universe, doesn't it?
It does. And it's a reminder that we're not just passive observers. We're active participants in this grand cosmic narrative.
I like that. So our sources mentioned that studying reionization isn't just about looking back in time. It also helps us understand the universe as it is today.
Oh, definitely. Reionization left a lasting mark on the universe.
Like what?
Well, for example, most of the hydrogen in the universe today is still ionized.
Ionized from back then.
Yep. It's a direct result of reionization.
So if those early stars hadn't done their thing, the universe would be a very different place.
It would be much darker and less hospitable, for sure.
It's amazing to think about all the little things that had to happen just right for us to be here.
It is. And it makes you wonder what other secrets the universe is hiding.
Speaking of secrets, our sources ended their piece with a really interesting question.
Oh, yeah. What was it?
They asked, if the universe can go through such a dramatic glow-up, what's stopping us from finding our own?
That is a good question. It's like they're saying if the universe can transform itself so completely, why can't we?
Right. Maybe we all have our own reionization waiting to happen.
Maybe we do. It's definitely something to think about.
So reionization isn't just a cosmic event, it's a source of inspiration.
I think so. It reminds us that change is possible, that even after a dark age, there can be a brilliant dawn.
That's a beautiful thought.
Mm.
But it also makes me wonder what mysteries about reionization are scientists still trying to solve?
Well, one of the big ones is figuring out exactly when it ended.
Oh, right, because it wasn't like a sudden event.
Exactly. It was a gradual process.
Yeah.
So pinpointing the end is tricky.
I see. And are there any other big questions?
We're also trying to figure out the exact role of black holes.
Black holes.
Yeah, they emit intense radiation too, so they might have contributed to ionizing the universe.
Wow, so it's like a cosmic detective story, with scientists piecing together clues from billions of years ago.
Exactly. And with new tools like the James Webb Space Telescope, we're getting closer to solving the puzzle.
That's exciting. So it sounds like there's still a lot to learn about reionization.
Oh, absolutely. There's a whole universe of knowledge out there waiting to be discovered.
Well, this deep dive has definitely been an eye-opener.
I agree. It's amazing to think that something that happened so long ago can still teach us so much about the universe and ourselves.
I mean, it's kind of hard to wrap my head around it. Billions of years ago, this thing happened, and we can still see the effects of it today.
Yeah, it really shows how everything in the universe is connected, like one big cosmic web.
And reionization is like this key thread running through it all.
Right. It helped shape the universe as we know it. All those galaxies and stars and planets, even us.
Pretty humbling.
It is. And it's a reminder that there's still so much we don't know about the universe.
Yeah, I mean, who knows what other amazing discoveries are out there waiting for us.
That's the beauty of science. It's a never-ending quest for knowledge.
And every new discovery just leads to more questions.
Exactly. It's like peeling back the layers of a cosmic onion.
So this deep dive into reionization, it's really been a journey.
From those early dark ages to the birth of the first stars and galaxies.
It's like we've witnessed the universe's coming-of-age story.
And it's a story that's still unfolding.
And that's what makes it so exciting.
Right.
There's always something new to learn.
Absolutely. And I think that's the most important takeaway from all of this.
What's that?
That the universe is constantly changing and evolving, and we're a part of that story.
We're not just observers, we're participants.
Exactly.
Yeah.
So the next time you look up at the night sky, remember the incredible journey of reionization.
Remember that the universe went through its own glow-up.
And maybe it'll inspire you to find your own.
Because just like the universe, we all have the potential to change and grow and become something amazing.
Keep exploring, keep wondering, and never stop being curious about the world around you.
And that's a wrap on this deep dive into reionization. Thanks for joining us.